Welcome to Quality Digest Presents, your source for what is happening in the world of quality and metrology. I'm Dirk Ducharme, Editor-in-Chief for Quality Digest. In this first part of a two-part series, we are going to explore the concept of autonomous versus automatic metrology and some of the various components that go into it. This field is growing exponentially fast, particularly with the advent of AI. Now, the easiest place for us to explore this topic was at Hexagon's user conference, Hexagon Live, which they hold every year in Las Vegas. Hexagon certainly isn't the only company that is working on autonomous metrology. But because Hexagon metrology hardware and software currently touch on pretty much all aspects of what is required for automatic and autonomous metrology, and because they've developed an ecosystem called Nexus to support it, the Hexagon Live show was really a good place to sit down with experts on this topic and find out what is being done with it. In this first part, we interview Gary Peacock, General Manager for Metrology Software at Hexagon's Manufacturing Intelligence Division. We learn the distinction between autonomous versus automatic metrology and how artificial intelligence ties into that. We also talk about digital twins, what they are and how they tie into this concept. And finally, there's the people component. What function do skilled employees have when machines start making key measurement and production decisions without operator intervention? Here's our interview with Gary. And with me here today is Gary Peacock, General Manager of Hexagon's Metrology Software business. What we're going to talk about today is automated metrology. But before we do that, let's get on the same page what we mean by automated metrology. So how does Hexagon define it, or what do you mean by automated metrology?
So automated metrology is really around the digital reality of the space. And it's probably easier for me to explain the data transformation journey because the autonomous is at the end of that journey. So we start with raw data. This is coming from your stationary or your portable devices. That is then given a structure and that transforms into information. So we've got data, we have information. So information is really played with PCDMS and Quindos and Spectral Analog Inspire. Those are the types of products that are playing with information because they provide a context to the data. Once that context is added, it transforms to knowledge. And that knowledge is really where we'll be playing with quality assurance, asset management. It's an understanding of what's going on in the environment. So you have an understanding of what's happened. And that's really important because it's all historical. It's what's been going on. And most of the applications today stop at that knowledge base. That's really where it is. If you're able to digitize insights, so this is digitizing domain knowledge largely. So this is the expertise of the people on the ground who do the job for a living. You can add insight to knowledge and that transforms, you can add insight to the knowledge and it becomes actionable insights essentially. So it's an intelligent action that you can take. So our metrology reporting tool, which I think you actually talked about a little while ago, that is really around that space. That's about looking at all of this wealth of now data, information, knowledge. What can we do with that? What does it mean? So this is where you combine measured data with asset data, with environmental data, whatever it is. So you've actually got a really good understanding of what's going on. So you can start to take action. Where autonomous comes in, it's actually adding a deep learned model understanding. So this is where the AI, the deep learning, the machine learning comes in. Once you've actually got that understanding at the knowledge level, apply models to it, actually use AI. So you can actually understand why things are happening. You're now at a point where you can predict what will happen based on a set of circumstances. So for us, autonomous metrology, it's about taking the minimum input, so maybe CAD and a PMI, a digital twin of the machines that you want to be running on, and then with the models and the understanding that we've got, optimize the program to actually go and measure the features that you need to measure. So this is really about simplifying for the user. It's all about usability, it's about efficiency, productivity, because some of the challenges that we see with our customer base, there's a demographic shift. We're actually seeing a reduction in the amount of metrology skilled engineers in the marketplace. That's just natural, absolutely. That's happening. So one of the challenges we've got to do is to capture the knowledge before it leaves the industry. And it's as true for us as an organisation of Hexagon as it is for our customers. We have to do that. That allows us to give the context to move it into actionable insights and then into that wisdom bit at the end. So one bit is around the demographic shift. We're also seeing that there is a need to standardise. So in today's version, you've got 5 metrologists. They're building a program on a machine. Each program is a bit different. So there's already differences that you're going to have within your standards. With our autonomous solution, it actually creates a plan so you know what it is that you want to be measuring. It can then generate a program for any machine configuration that you've got. So immediately you're cutting out any standards or any deviation from those standards. So it's much easier. And it's much faster, it's much slicker. And the whole objective here is we can automate as much as possible the entire measurement program and process. And that leaves the engineers who are left in the industry to do more valuable things. So they can actually look at the resolution of those issues. And autonomous for us is not just about measurement. It's actually about going into a closed loop. So as you're measuring something and you're understanding what's going on, do I need to make changes to my machining? Do I need to make changes somewhere else in the manufacturing process? Even taking the end results and re-simulating that to confirm that the component you've got is structurally sound and correct.
Let me interrupt for just a second, because there's a couple things you've said that I want to make distinctions on. So we talk about automation,
yes,
and we talk about autonomous.
Okay.
Autonomous would be kind of the step beyond automation. Automation, a robot is on, but it does the same thing every time, whereas autonomous is making its own decisions.
It's self-learning, absolutely.
It's self-learning, okay.
And the more data that it has, or the more experiences it's exposed to, the better and sharper it becomes.
Okay.
So it's really about marrying up real-life experiences, learning from that, digitizing that, and becoming better the next time it actually comes across that situation.
Okay. So that sounds like, so you did mention AI. So AI
Yes.
is a component in this where it's based on the data, the hard data that's
Yes.
being collected, and on what, historical operator input, operator feedback. It's learning what to do.
Yes.
I mean, is that, and when we say learning what to do, in terms of controlling the machine or predicting what may be an output of the machine, but the operator still has to step in and make the changes. You follow what I'm saying?
In the automated space, yes, the operator steps in.
Okay.
In the autonomous, you imagine that we are identifying components under machining, and a drill bit is starting to wear away.
Right.
So we're able to detect that change in those features that we're measuring.
Okay.
We can automatically go back and adjust the program of the machine, of the CNC itself.
Right.
So we can cater for what's happening and making sure that the component coming out is exactly within tolerance with what you're looking for. So we can do self-adjustments. It doesn't need an operator at that stage.
Okay.
So that's the difference between an automated solution and autonomous.
Digital twin has been thrown around so much within our industry. I'm still not real clear, and I think probably a lot of our readers aren't real clear on what digital twin is and how that ties into what we were just talking about, autonomous and automatic and so forth. Okay.
So a digital twin, imagine we sort of need 2 types of twins. Okay. One is a 3D CAD model of the component that you're wanting to simulate and measure. And that's one digital twin. The other is an exact digital replication of the machine or the parts you're going to be measuring it on. Okay. So this is a complete, with all the movements, the angles, the knuckles, everything actually modeled. So we've got the full telemetry and sort of mechanics.
So we've got the model of the CNC,
yes,
as well as the model of the part that the CNC is cutting.
And everything.
Or a CMM and everything else, right?
In that.
Yeah.
So, and that's really important for us because that's what we're working with in terms of data.
Okay.
So when we're looking to create the optimum path, we have to make sure that there are no collisions.
Right.
So for that, we need an accurate representation of what's going on. So we've actually just developed a very simple drag and drop tool to build a digital twin of a CMM. Future things will have actually cameras on, so we can immediately detect what probes or scanners or things are present. That will automatically populate. So we've got a really easy way now to create the CMM, which has always been really complicated. The CAD essentially comes in, you marry those two together, and then what our software is really looking at, if we take it back a little bit further as well, so either the CAD comes with PMI attached, and that PMI is essentially telling us what we need to be measuring, what the tolerances are. That's really what we need to be looking for. But we also, within Hexagon, have our design and engineering team who do simulation. Okay. Component simulation, process simulation. So we're able to actually simulate the process and the component, and the simulation can identify critical features that we should be measuring. So even if it's not on the PMI, we know that that feature is structurally critical for this part in the future. So we can add and layer all of this information on top. So we start to measure what needs to be measured. And where autonomous is also a little bit different, most of what Hexagon has done historically, and most people in the industry, it's dimensional metrology. Sure. So you're looking at the outside shape. Right. Hexagon a few years ago acquired an organization called Volume Graphics. And Volume Graphics is essentially a 3D CT, 3D X-ray organization. So we've got all the analytical software that connects with multiple vendors. That allows you to start to look inside the shape. So we can start to get a picture on the porosity, the inclusions, the cracks, the tears. Right. That is actually critical for us because our autonomous solution, it's about that. It's about the entire integrity of the part. So it's not just dimensions is an important part, right. But so is the internal structural measure. So we now got material properties within there, and simulation helps us flow this all the way through. So sometimes porosity is okay, as long as it's contained in an area that's not critical. Exactly. Yeah, exactly. That's what we're measuring. So for us, the autonomous is broader than just dimensions. This is actually about not only will this component fit in the hole it's meant to fit into or join the thing it's supposed to join to, but is it structurally sound? Will it fail in use? And that for us is one of the big important step changes for autonomous. And to do that, you need a connected workflow. It's all about collaboration. Each of the users, essentially you've got a designer who really isn't a manufacturer. You've got the production guys, the machinists, you've got the quality engineers. All of these have slightly different views of a problem and the resolution. So our autonomous solution sits on Nexus. Okay. Nexus, as you've seen, is the new ecosystem that we've got, essentially the new platform. Yeah. And that is driving data alignment. The digital twin is consistent throughout that entire workflow. Okay. So that no matter where you are, it's the same twin that you're looking at. But I think probably for us, one of the most important benefits we're seeing immediately is the degree of collaboration. So you identify an issue and you can actually invite the designer to come and have a look. Does the design need to be modified? Right. For the machinist, is there an issue? Yeah. And it's all on one place. So it's like a Teams meeting. Yeah. You all contribute, you can see, you can use the tools. So for those sorts of collaborations, our metrology reporting tool is probably the most visual. Because you can spin the part around, you can see where the issues are, have a discussion around what are we going to do about that. That's really where it is. But a lot of the way that the data is collected, that's the next stage, the wisdom bit, which is autonomous. Okay. So Hexagon actually has an amazing part to play in this because we've got the end to end. We start with the design, we go through sort of the manufacturing, the prototyping, the production, the machining, all the way into the measurement, the quality management. And we believe actually you need that entire end-to-end workflow to be able to drive smart manufacturing. And that's the autonomous space that we want to play in.
So once this is all in place, and I think you said earlier, we're not quite there yet, but we're getting there. You said that in the end, this will free up the humans to do the things what humans are really good at, which is really resolving problems, solving problems. But in the meantime, obviously, there are jobs that are probably being eliminated at the same time with automation and so forth, right? So, and that's always a topic that comes up anytime, obviously talking about automation for a long time, anytime automation comes up is what's going to happen with jobs. Now you're hearing it again with AIs, oh my gosh, AI is going to take my job. There's always a certain amount of truth to that. So how does Hexagon look at that in terms of, yeah, we've got this great technology, but oh yeah, some guy who used to be his job, well now, the computer's doing it. How does Hexagon look at that, and how do they suggest industry address it? Or maybe how does even Hexagon address it?
Okay, I think there are two dimensions to that. I mentioned earlier about the domain expertise.
Okay.
And today that's largely in people's heads and in their hearts and in their stomachs. It's a gut feel sometimes. So you've got tacit and explicit, which we're really sort of trying to explore. So one of the challenges I think any organization has is to digitize that expertise.
Right. Yeah. Get it out of their head. Yeah.
Get it out of their head.
Yeah.
And you need time and energy to do that. So as people maybe are not so busy because part of their role has been replaced with an automation, robot or something else, their expertise is still critical to actually capture because it's the manual part that's been replaced. It's not the intelligence, it's the manual part. So the intelligence comes from the digitized expertise that we capture. So there's a whole host of techniques that are used to capture that. So I'd actually argue that automation is accelerating this digitization, and there's a huge value in that, absolutely. So that's one dimension, and then the other is how you're actually deploying that, because the deep learning, the machine learning, it needs real experience to drive. And the more experiences it gets, the better it becomes, and that's essentially a self-closed thing. So the knowledge, the domain expertise falls in a number of places as the capture and exploitation of that. And what we would actually recommend, we see it ourselves, as we free up time, there are new opportunities to go and explore. So every organization really needs to be looking to expand, to grow, to look at sustainability, look at other things. You can't necessarily have an unlimited resource base to go and do that. Right. So freeing up the mundane tasks actually allows you to go off and do these other things. So you become stronger and more sustainable as an organization. So we're not seeing actually a huge loss of people, it's a redeployment of people. Okay. And that's actually what we're seeing.
But there has to be a training component in that, obviously, right? Because you got this guy who's been a CMM programmer, and now the computer can program the CMM for him, right? So now this person needs to learn a different job. Yes. So where does that training come from? Is that something that companies like Hexagon are taking on? It's like, okay, we're going to start training the next group of people for the next kind of jobs that are coming down the pike, or is that more the responsibility of companies? Look, this is going to happen. You're buying our equipment. It's replacing jobs. It's your responsibility to take care of these people and to train them up, right?
I think it's a partnership. But I will just go back to the very first point you made. Okay. Even though we are autonomously creating programs, there is still a requirement in many cases for a skilled engineer to take that program and maybe edit it or align it or adjust it. So in day one, it's going to be a number of years until we're ready to be fully autonomous. Yeah. So there still is this hybrid relationship that we have. So skilled programmers are still really important in that process. But to your second part of the question, I think it's a joint-owned partnership. It's joint ownership, really, of this training. So we're already seeing new technologies, new ideas coming in, and we're going through the same ourselves. Sure, yeah. So we're doing a reskilling, of some of our longer-standing teams because the world has evolved. So we're actually helping with that ourselves. And I think as we learn, and as other technical vendors learn, that transforms itself into learnings for the industry that we can drive. But it also means that we need a responsibility with our universities and institutions. So we're actually training the next generation to come in. Right. It's not all about the existing, it's about those coming in as well. Right. So, and that isn't just on us, remember it's Hexagon as other vendors, it's on us jointly as an industry, as a society. Right. So, you know, that's really to Paolo's point as well, you know, it's you, it's society, and the collaboration, that's really what it's about. And, you know, the Hexagon values, that is really at the core of what we're trying to do.
Okay. And final, I guess final question is, where do you see manufacturing autonomy going? Are we kind of approaching the real honest to goodness lights out factory? Are we close to that? Is that still 10 years off, 20 years off, where you know you drop your CAD drawing into the computer and you got your hoppers full of material and you flip the switch and you walk away and it just magically makes itself? Yeah,
it's different for different industries. Yeah. But lights out is where we're coming, you know, and I don't really want to give a prediction. It's not going to be 2 or 3 years. Yeah. It's going to be slightly further down the line than that. Because there's a whole host of legal issues, of you know, guarantees and warranties. There's a whole host of stuff that we need to be sort of looking at from that. But there are, I mean, there's some examples given yesterday on stage of organisations that are so streamlined that once you've actually done all the optimization up front, the system takes over and starts to either 3D print or assemble or create. So there's still people involved in all those stages. Yeah. But that's really a drive towards a fully automated plant. But that isn't still lights out. So it's the journey that we're on, and I think technology and environment and society will actually dictate when that happens. But it's certainly a journey that we're on.
Yeah, all right. All right, Gary Peacock, appreciate it, man.
Thank you.
Very good, thank you.